And so for me personally, the technology side is always stuck with everything that we design, and the ground up concept. So we don't buy a tweeter, we don't buy a mid-range and then build it into a cabinet. We design the tweeter purposeful for example, an R5C. That dome is the windings of the voice coil to the magnet to the T-yoke is all designed by our team.
Hey everybody, I've been kind of fumbling around with my family room theater, and I was trying to do it, on the inexpensive, and I wasn't I was doing it very utilitarian, just kind of picking some stuff and putting it in my room. Well, I decided to just do it right, and so I'm living this bizarro dreamland where I get to get the guys come to my little house here in the middle of nowhere, Florida. And so Dan and Steve, so Steve represents Fidelity Imports, so you're the importer and the distributor, the main distributor for the product.
Yes.
Dan is the founder and brains behind the Perlisten stuff. So I'm not blowing smoke at you guys. When this showed up in my living room, this big pile of stuff, before I was putting the speakers in here, and I kind of liked it, and it was okay, but I didn't get that that feeling when you buy something that you shouldn't be buying. That's you get that butt puckering moment when I had to pay Steve's invoice, right? But then when the product, once the money's gone and the stuff is here, I kind of get that flutter. And so what's even better in my bizarro dreamland is I get the guys that make the stuff here to help me open it up. And so I was hoping while we're kind of going through this, we can kind of go through the story of Perlisten. I'll tell you guys a little bit more about Obsessed Home Theater. Michael's here, as well, and what we're going to be doing together. I sort of pitched you guys on the story and how unique the Obsessed Garage and the Obsessed Home Theater story is. And then us kind of working together, making I think something different available to people is the story here. So our series, Dan, can you tell us first, while I'm kind of opening this up, can you kind of tell us how did Perlisten start?
Oh, okay. That's kind of a long story, but
well, we got a lot of stuff to open up.
I personally have been designing loudspeakers since the 90s, ground up. So me personally was always engineering technology, looking at ways to do models of loudspeakers and come up with new designs for a purpose, whether it was doing OEM speakers. The first speaker I worked on was the F-Series F-150 truck.
As an engineer?
As an engineer.
Okay.
And believe it or not, for a $5.50 speaker, there was a ton of engineering going on because you were optimizing every part.
Gotcha.
And that knowledge base that you gain on every single component, from the spider to the surround to the magnetics, all that technology you need to do the simulations carries over into the high end. And so for me personally, the technology side is always stuck with everything that we design, and the ground up concept. So we don't buy a tweeter, we don't buy a mid-range and then build it into a cabinet. We design the tweeter purposeful for example, an R5C. That dome is the windings of the voice coil to the magnet to the T-yoke is all designed by our team. Okay. And then manufactured at our factory in China. So anyway, that's the backbone of me, and that's the backbone of Perlisten. So over time, whether it was doing stuff OEM, doing stuff for other brands as a consultant, I kept running into the same group of people, being Eric, being Peter, Steven, Lars, and our paths kept crossing. And at some level, we were doing projects all together, or maybe just a couple of us. But then you get to a point where you're having a beer and you're like, we have a company here, we might as well.
You have all the talent, you have all the people, you have
all the parts
knowledge.
are in place.
Yeah.
And so it was just a simple matter of create the company, because we had all the parts and we were already doing the type of projects we needed. So the first step was to create a consulting, engineering, manufacturing consulting team to do for other brands. And that's really the genesis of Perlisten, where we were able to, what I call put a lot of sweat equity in, save some money in the background, take a little bit of paycheck to live, but then generate Perlisten. And that's why when we came out with Perlisten, Steve helped me, how many SKUs did we come out with? Close to 20 right out of the gates.
Yeah, I've never seen a company come out of nowhere, especially in the speaker world, and launch with like 27 SKUs. Right? Somebody starts to test the water with a product or two, but all of a sudden they had a lineup. And then we're already working on a secondary lineup out of the gate. And it was crazy because it was a rocket ship. Right? From the very beginning, you know, traditional media still had a place then, and I distinctly remember myself, my partner, and my son, who was 13 years old at the time, carrying our first pair of S7Ts, first pair in the world, to a Stereophile Reviewer's property on the 11th floor in Manhattan. So if you can imagine getting these things, you know, you've moved the R7T, the S7T is a little beefier in terms of
and it's
weight.
Slick too, because it's shiny.
Yeah,
so you're trying to hold on to it.
And the moment where we knew, I mean, we knew that these guys were doing something different. We knew it was science-based. But the moment I knew, the reviewer, and I've done products with him for review before, he's very tight-lipped. We set the speakers up and we said, look, we're not going to say anything, we're not going to do anything, no influence. We'll put the speakers in the room, we're going to make sure they pass musical signal.
Just play.
And we're walking out. And so the first cut comes on and he goes, whoa, 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 whoa. And he starts walking towards the speakers. And it was like, we got you, right? And then we walked out of the room and we left and we were on the cover of the magazine.
When was this?
Oh, shoot, was that 2021, fall of 21?
2020 or 2021.
Okay, so only 3 or 4 years ago, right?
I mean, we've only really been, as a brand, we've been around, this is our 5th year. We're just starting our 5th year. And so that was the end of the first year, I believe.
So just to help people, because people always want to know, like, so you make them and you provide, you're the distributor. So to tell us a little bit, how does distribution work in this world? Just briefly, so that the audience understands what the heck we're talking about.
It's a little different with our relationship. Some companies create a distribution model where literally they've designed the products, they make the products, and then somebody else brings it in and fulfills the orders. What we do, and the reason why our company's Fidelity Imports and not Fidelity Distribution, is because we do a lot more than that. So we help them with the sales aspect. We are, in fact, their sales force in America. We help them with the marketing. We create some of the content. And then we obviously represent them at trade shows, and we help them do the strategy on what retailers, what integrators in the country.
So you guys can stay in the engineering.
And we can stay small. I mean, people always ask me the question, how can you be so few people and be in 55 countries, for example? But this template works really well where Steve and his team, they're experts in what they do. I'm an engineer. I know the speakers. I know the guts, the science, but I don't know the sales, the marketing, the distribution. And that's where Steve and his team really create a lever for us to accomplish the things we need to accomplish. And we do that globally.
So let's talk a little bit about this. So I'm doing R series. Did R series come first or S series come first?
S series was the main, let's call it the project of Perlisten. And then as we were about halfway through the development of S series, we realized that there was a need for a cost down. So really we're taking all the technology of the S series, you know, everything we did with the DPC array, how we integrate the waveguide, how we do the crossovers, how we do the beam forming, all that from S series is applied to R series with the engineering pressure to do it for a much less expensive price point.
So where you make the adjustments is in like material cost, like so you look to save money and cost, but try to perform at the same level as money no object.
And that's the wonderful engineering challenge, right? How you always, when you do a cost down product, it isn't, it's cheaper, so I can just stop engineering it here. Actually, it's the other way around. You try and get, in this case, an S series level performance, but you have a budget restriction, so you're challenging yourself on everything. Well, if I cut a part, you know, is it going to affect the performance? Like, for example, in the crossover networks, initially, you know, you can save money really fast. You know, looking at tolerances, we're like 1 or 2% tolerance depending on what components. And S series initially looked at relaxing that to 5 or 10% on R, but then we started doing measurements across components and we're like, just can't do it because unit to unit variation is too much. So we had to go back to the 2% component tolerance on here.
So instead of 1, it's 2.
Yeah, and then you know, iron core inductors, we looked at that, but when we did listening tests, we couldn't let it go because the sound quality of the air core, just little things, you know, small amounts of distortion when you have transients in the music would show up with the iron cores, so we went back to the air cores. It costs money, so you have to put it back in. So where you save money, you know, you got to be very careful. Cabinets, they're smaller, not as thick. The painting process isn't quite as extensive. We're not using the beryllium. We're not using the tech stream.
Okay.
And somewhat simplified on the componentry and the crossovers. So yeah, I don't know what the best number is, but you get 85% the performance of an
I think it's
S-Series.
I think it's a little higher.
For half the money, right?
Yeah.
And one of the reasons why I think that for somebody who hasn't seen Perlisten, one of the things that jumps out immediately is they look different. Why do they look different? And it's this central array right here that you see, the DPC array. And I think it was critical, and this was one of the most important things Perlisten got right at the very, very beginning, was if we're going to scale the technology, if we're going to scale the brand, this is essential, critical to the success of the R series. We are not going to go away from the DPC array. So this central array with these 3 drivers here is core to what Perlisten does.
So DPC stands for?
Directivity pattern control.
And so why don't have like a normal mid-bass driver, right? Like this fancy.
That's an awesome question. That's exactly, you know, why the DPC array exists. So for me to explain it, the easiest way is to start with just a single dome tweeter. Okay. So a traditional speaker would have
thing, right?
just one tweeter in the middle sitting on a flat baffle, and that's good, let's call it.
Okay.
What are the limitations of that? Well, at the lower end of its bandwidth, the polar response is very wide.
Okay.
As you get higher up in frequency, it tends to what we call beam, so it narrows its dispersion pattern.
Okay.
So now you have, as the energy is going into the room, the reflections coming back are going to have a disproportionate energy, meaning there's going to be an emphasis on lower end of the tweeter versus upper end. Okay. So already you have an unnatural in-room response. If I stop for a second and you talk about the goal of the loudspeaker, it's not just the first initial wave coming off the speaker to your ears. It's, you know, you can hear me talking in the room. You hear the room.
For sure.
So it's how that speaker utilizes the room. And I always say the on-axis response makes the promise of what the speaker is going to sound like, and then the reflections deliver on the promise.
Okay.
And if you can't deliver on the promise, then it's a ho-hum experience. So back to the tweeter and the DPC. So now we know we need to control the dispersion so that you can deliver on the promise, right?
Okay.
So that's the waveguide. So now you see the waveguide around the dome. So now I have the ability to control the tweeter's response from its lowest frequencies to its highest frequencies, have an even dispersion. Some people call it constant directivity. We're not quite in that mathematical place, but it's very similar to that. But there's other benefits. On the low end, you actually gain energy. So the way we use that is we lower the distortion of the tweeter. And then the next question is going to be, okay, well, isn't that good enough? Why don't we stop at a tweeter plus a waveguide? Well, again, now we're talking about the highest fidelity we can get. And what I've found is the wider range that you can control the dispersion, A, and B, in the smaller transducer, so lighter, more transient perfect, and just overall more controllable frequency response. The more bandwidth you can cover with that, the better the vocals will sound. So in the case here, the 10 dB point on the DPC is roughly 1200 hertz. Okay. A single dome on a box, if you tried to play it just at a normal level, you'd probably blow up that dome tweeter. But here now we'll talk about the 2 mid tweeters, if you will. They're actually, in this case, they're the same driver. There's 3 of the same drivers.
What are they? Is it a dome?
It's the exact same one, but it's recessed in, and that was where a lot of the Eric, my partner, who was here earlier, he does a lot of the ComSol multi-physics modeling, where I'm creating these geometries and then I'm rolling out the designs to him, and he's doing the simulations. Where to put the dome on a waveguide, superimpose it, and not screw up the frequency response is a real challenge. And so we spent the better part of a year figuring out the best way to integrate these domes. And why? So we could expand the bandwidth of this DPC array.
So the dome is on the curve of the waveguide
It's as close to the curve, yeah. And then how we do the grill, we actually have patents on how we do the grills. And you see it on our in-ceiling speakers too, where we have a much bigger version of this. But integrating that in, so you create still a very smooth frequency response, but you're able to get these two domes close in proximity. Why? So now the placement of those relative to the central allow me to control the vertical response. That's now the beamforming we're talking about.
Okay.
So be able to control the vertical, not like a laser beam, but plus or minus 20 degrees roughly, very even response. And then after plus or minus 20, so as we're getting higher and lower, it attenuates rather quickly. So we don't have as much floor and as much ceiling reflection, which can be distracting. So now again, we're talking about delivering on the promise. If you have a really hard reflection that disrupts the frequency response at the seating position, you're going to have, at best, challenging outcomes in different rooms, and each room might be different. So the more we control the vertical, the more we can guarantee a good starting experience in the room, even before you do the treatments in the room.
So why did you put a grill on it? Why didn't you just leave the tweeter open?
Great question. Without the grill, a complete mess for the central tweeter. So as the energy comes off the waveguide, that would be a really bad discontinuity. So you'd get reflections, or some people call it diffractions, coming off of that cavity.
So did you know that in simulation, or did you?
That's a big part of the simulation.
Did you find that out after sticking three tweeters together?
Well, intuitively, you just kind of know it's going to be a problem.
Okay.
So we knew we had to spend time on the grill designs, and like I said, the evolution of those on the in-ceilings.
And then the positioning is very precise on the width of the full array, right? Or the
exactly.
Like it's kind of weird. You put it on the curve. Wouldn't it be easier to just put it on the flat?
Exactly.
Right?
And why wouldn't you put it further away? Because then it would just be out of it. Well, so when you're talking about the frequencies of interest, they have to be within the proper wavelength to do what they're going to do. At the lowest frequency, let's say 1200 hertz to
So this array is crossover at 1200.
Right,
Okay.
and so all three of those domes are doing exactly the same thing. They're essentially seeing the same energy and playing together. Why? Because the wavelength is roughly the size of your head almost.
Okay.
The size of the DPC, so it actually looks like a point source.
Yeah.
Interesting.
As you go up in frequency, then all hell breaks loose. If I were to try and do that, then you would have all sorts of interference patterns between the different drivers. So that's where the complexity of the crossover comes in, where you start.
So the secondary
pulling these
tweeters
out.
are crossed over, so they don't play all the way up.
And it's a relatively complex where we use them to control the vertical.
Okay.
We actually use them in some places to attenuate the vertical. In other places, they're filling in where the tweeter can't.
So there's shelf filtering in order to.
And then eventually we just get rid of them. And so
Gotcha.
let's say about 4 kilohertz on up, it's really just the central tweeter and waveguide.
Interesting.
And there's a few cool things to point out, and maybe a little less tech.
Oh, sorry.
I love it.
Dan can go crazy.
Yeah, simplify it for me,
right?
Steve. Yeah.
But there's a few things there that are really interesting to point out. One, and we always ask people to do this, it's a lot easier on a floor standing speaker than a center channel. But one of the couple things that you want to do to see where's the proof in all of this science, right? How does it end at your ears? What do you hear?
Yeah.
The first thing you want to do is when you're listening to a pair of Perlistens, put your ear right up to the central DPC array and see if you can localize the 3 units. And you won't be able to. Even that close with your ear up against them, it will sound like one continuous unit playing.
Okay.
Right? So that's the proof of the science that they're working in tandem together. A couple other things that are kind of interesting about it. Because of this arrangement, the sensitivity of the majority of the higher frequencies, or all of that kind of range from 1200 hertz and above, is at a super high sensitivity level. I don't remember exactly off the top of my head.
I would have thought the opposite. I've got 3 drivers now. I'm going to need more power, right? So I'm going to be less. I'm going to be less sensitive.
You don't.
Yeah. So if we go back to the starting point of the conversation, the single dome in a cabinet, let's say that's an efficient tweeter. It might be 90, 92 dB. By adding the waveguide at the lower frequency, you get 6 dB in this case.
Okay.
And then adding the 2 additional, we actually get. In total, we get like 10 dB advantage over the single dome across the band that they're playing. So it's like 100 and some odd, because this is like a 92 dB tweeter, so it's like 102 dB efficient.
Interesting.
S series is 110 dB.
Yeah.
So now if you go to like compression driver category, you have that level of, not quite, but you're approaching the performance as far as SPL capabilities, but you're not sacrificing any of that sweet soft dome sound.
Yeah.
And what's cool is, so this
what I'm
speaker is
hearing that I
about
like.
89 or 90 dB efficient. So from that 102 to 90, I pat it down. What does it do? So if, let's say you have frequency response here and distortion here. If you pat it down, the distortion actually goes down disproportionately. So you have zero distortion. So a hallmark of Perlisten and anything with the DPC array is that in that 1 to 3 kilohertz range, where your ears are the most sensitive to distortion,
That's what drives me crazy.
no matter what level you play the Perlisten at, that's the lowest distortion it'll measure across the entire bandwidth. And that's the complete opposite of a single dome tweeter or a horn compression driver, that type of thing.
And I'm a total nerd, so I watched the video with you and Michael, and you were messing around with the PEQ and things like that that you were messing with, and you picked up on it because you clearly have a sensitivity to some of that. And when you were adjusting,
Some
we noticed
people are
you weren't
very
adjusting
sensitive.
that range with these speakers, which you probably didn't even get.
Yeah.
You probably do more with other speakers.
Yeah.
And that's a hallmark. The last thing I wanted to point out too, which is really cool on this speaker, or in this array, is that when you're in the seating position, one of the things you're going to notice is that the actual sweet spot is higher. The vertical size of the sweet spot is higher on a Perlisten speaker than most other speakers. So when you're sitting down, there's very little difference in the sound quality as you stand up. Right?
So that would help in a theater where you've got, rows.
Yeah, and exactly, and that's in the cab. We talk about the cabinet speaker, the tilt back, so the wavefront as it's coming out.
Okay,
right?
yes. So I didn't adjust any of the real leveling on this. So,
So you got a couple
this
degree-
little rake is by design. Yeah.
Exactly. So now you picture the wavefront coming off of the speaker. The further you go back,
So you can see the
higher
rear,
the sweet spot.
rear sits a little lower than the front.
Yeah.
And so here's the same DPC array. And so how important is it to timbre match especially your front three?
Well, I think if you want the highest fidelity, not just from your 2-channel, but if you want it in the theater. So now in a theater space, you're going to have left, right, up, down, front, back panning.
Yep.
And I've heard horrible examples of wonderful speakers in the front and then mismatched speakers in the rear. And as the effects happen, it goes from a good experience to a very distracting experience.
It goes like null to a null and then into some, instead of panning, like if something was flying around you or something like that.
And honestly, that was a big part of the Perlisten. We talked about launching all the products together. As I was creating the S7T was more or less the first speaker, I developed what I call the Perlisten family of curves. So if you look at the on-axis, off-axis, the power response, all we talked about, delivering on the promise, we actually created a set of curves, family of curves that are like the template starting point of every Perlisten speaker. So you can actually, within reason, take an S, this is an R7, R7, and from 100 hertz to 10 kilohertz at least, or maybe even up to 20 kilohertz, and you look at the family of curves, you'd have a hard time distinguishing the two from each other. So they start with that same, and that's the timbre matching. So you can't timbre match because both cones are yellow. I mean, that doesn't make timbre matching. Yeah, from a marketing pamphlet, oh yeah, they're both yellow, so they must sound the same. No, sorry. So it's not just, is it the same materials that we're using, it's now all these critical underlying performance criteria, using the same dome, using the same DPC array, but then how we do the crossover and how we make it work within the room. That's true timbre matching. And honestly, I think that's where Perlisten sets themselves apart from the rest of the industry is now, no matter which, in the R series, in this case, which speaker you're putting in, it's going to timbre match within its bandwidth, right?
As long as I'm within the
a surround
line.
speaker won't have the bass of this speaker, but in that 100 to 10K, it's going to be very similar.
So how does the R7 has so we have our DPC array in an obviously specific location, right? And then we have, are all 4 woofers crossed over at the same?
So no.
So how are the woofers working and functioning in this cabinet?
Yeah, good question. So 1200 hertz on up is what we were talking about with the DPC array. and we're controlling the vertical probably down to about 800 within that.
Okay.
Array. And the idea is then to not have an abrupt change in the polar response as you transition from the DPC to the woofer. So then these two woofers will play up to that 1200 hertz,
Okay.
but not the outer.
Okay, interesting.
And so that allows me to control the vertical another octave or so lower.
Huh.
And then likewise, the outermost
We play down.
play down. But then you're using all four for bass frequencies. So if you look at it from the other direction, all four play the bass, then I cross these over at about 400, and then I cross these over about 1200.
Interesting. Okay.
And then across these over about 4K. And that's how, if you look at, and we publish on the website, you can see the polar response in the vertical from, and these probably 300 hertz all the way to 20 kilohertz. I'm trying to like show the picture, but basically it's the same energy, plus or minus 20 degrees on the whole speaker, and that's what we call beam forming. And so all of our speakers have the beam forming. The DPC is the starting point of the beam forming, but it's really the whole array. And you think about it, the larger the array, the further down in frequency the beam forming works. So here, 300 hertz and S7 is like 250 or something like that. The R5 is an octave higher, so it's like 600 hertz, somewhere in that area. R4 is not quite as low. But that gives you an idea of what they can do and how we handle the beam forming.
So an S would have different cone material.
They're a little bit
different-
bigger, and the array is a little bit bigger.
Yeah, the speakers like say yay taller and a little fat.
Deep, definitely deeper.
That you
yeah.
also it made mention the cabinet construction.
Yeah, more bracing. We actually put in damping material in there on the walls, so any vibration that is born in the cabinet will get damped out. Stiffer bracing, the baffle's thicker.
So did you think about it? Did you start at S7 and then start to take away, to design an R? I mean, is that how you go? You go with
Strategically
the
take
flagship?
away, right?
And then you take it away. Oh, that didn't sound very good. Let's put it back. All right,
Exactly.
and let's see what can we take away and still have an acceptable outcome.
Yep.
But there's a key point there, right? Which is, yes, take it away, but make sure that you keep the core tenets of what makes the speaker.
Right.
So you got the DPC array, and again, just to take kind of like that tech and make it back to every man, right? The further and further you domesticate a speaker, the less and less you're going to have treatment in the room. So what did Dan say earlier about the vertical dispersion pattern, right? You have a situation where they're already trying to accomplish the problems in the room caused by the ceiling and the floor.
Okay.
So the more and more traditional home you have, you may have some treatment. Where does it usually go? Front wall, back wall.
Yep.
Most people don't treat the floor or the ceiling. That's like far, far in there.
Yeah.
So if they can take that problem out already, you're starting with a better solution. Then it's a matter of customizing between the R and the S for what materials you like, the sound characteristics, and of course your budget.
So let me ask you this. So this room, I may add a little bit, but let's say there's no treatment. My treatment is the couch, the pillows, and the carpet, and the rug, right?
Right.
And so am I wasting my money putting this level of system in my basic room?
No, in fact, I think the opposite would be true, is where your advantages really stand out, where you can get high fidelity out of a room like this. And certainly in the couch here, you're going to have wonderful experience. And quite potentially in the whole room, for background music, it's, this is a very wide open area.
Yeah.
They'll fill the room, no problem, that's for sure.
What I'm interested in here is clear, controlled, not so much dynamic, watching a regular Netflix series at 7 p.m., right? But then I also want both.
Yeah.
I also want to, no one's here, 2 o'clock in the afternoon on Saturday and the kids and wife are out, I want to let it rip. That's what I want. And so what you explained to me, what I think I'm hearing DPC, because I'm very sensitive.
Yeah.
And so most people like the snap, I call it snap, that kind of mid-range in your face, high frequency in your face. I mean, bass is bass, right? That's easy, right? You just make bass but that mid-range, high frequency, what I've been missing with some of the other speakers I've been playing with, I love the fact that they're subdued and laid back, but when I'm watching a movie, I'm missing something. I'm missing the dynamics. But I don't want it to be so in your face that it hurts.
Right.
And so I think what you're explaining with the DPC array is why I like these so much. It's got that flat, that no distortion in the most important frequency range to my baby ears, but I still get the dynamics to let it rip. So let me ask you another question about this room. Currently, I have a receiver, 130 watt receiver. I don't have separates. I mean, are these too expensive and too fancy to be driven well off 130 watt? I have a Marantz Cinema 30. So a high-end, $4,500 receiver. Is that appropriate? Could I run a system on a $2,000 receiver at this level?
You could probably speak to use cases better than me, but
I mean, I think that one of the things you got to think about when you're on your journey, right? Whether it's a 2-channel audio journey, whether it's a multi-channel journey, is you can't always start at the end.
Right.
You want to put the majority of your money into the speakers.
Okay.
Right. Always. The speakers are the most important part in the chain. It doesn't matter who tells you what. It's the speaker. Always. It's the most important part. So you get a technology that you agree with, a timbre or a sound characteristic tone that you appreciate.
That's very important to me.
The tech is there, and then the rest of the system grows with you. Right.
Okay.
So you can absolutely start with a receiver. Could you scale the speakers with separates? 100%. There's also different levels to receivers, right?
For sure.
There are some that have high quality amplifiers built into them. There are people that are using Class D to a level that Class D's never been before, right? And I think that we have something hopefully very soon we're gonna talk to you guys about. I'm gonna try to show you guys something interesting for this particular room. But don't be afraid to put them with a receiver. Know that may not be your end game, and you will get to scale. And I think one of the things that's important for everybody, because it's a fun hobby. It can be a ton of fun, right? And you think about Michael and how I see his face when he goes to a theater and how he lights up. He's a little child when he's in there, right? And so you think about the journey you're going on. It's also important to recognize the differences. Again, if you start at the end, you're not going to be able to know. You're not as good a listener because you don't actually know what things made the biggest changes.
that's a great point. Sometimes I think that's half the fun is starting with that entry level. Okay, that's really good, and then you get used to it and you're like, well, what could I do to get more out of this? Well, try a different amp.
I just did this in like months. I just put a whole $20,000 system in, and I'm tearing it all out because I want to do it. But it's for the fun of it.
It is.
But you don't always have to spend a fortune either.
Right. I agree with that too. And I get accused of this all the time of being an elitist, and I just love it. And I'm looking to love a system, and I think I love it in the catalog, right? How many times have we done this with anything you buy in life? I think I'm gonna love that car. I think I'm gonna love the pants, the jeans that I'm buying. I think I'm gonna love the shoes. And you get it, and you sort of force yourself to love it, and then you realize maybe it isn't exactly what I thought it was gonna be, but then what I've had to learn over the years is don't beat myself up over it. Enjoy the journey. Enjoy it. Okay, I'm starting with a receiver. I'm going with speakers that are probably above the level of my receiver, but then I have headroom to go from there.
And I was just going to make one small point about the speakers, because we get this. Eric Wiederholtz handles a lot of our tech calls, but he gets the question a lot. Like, I like such and such amp, will the speaker portray the characteristics of that amp? And the answer is absolutely yes. Okay. So it's kind of neat where, like you said, Steve, if you settle in on the Perlisten technology, then you can experiment with different amps, kind of like to find your flavor that works. Some people love the tube amp sound, some like the exact opposite, and there's a myriad of choices in between. That's actually half the fun too, is like which one do I like? But the cool part is you don't have to swap out the speaker, because now you got a speaker that's working well with your room and your seating locations. Now try the amp, experiment from receiver to separates to whatever the choice is. So
I've been using this analogy with Red Wing. You know Red Wing shoes? Soda-based company, right? Incredible boots and stuff like that. The end is something amazing. It's a boot that's contoured to your foot, but you got to go through some pain to get to there, right? You get those boots, and the first few weeks, it's painful. You can't wear them all day, right? The footbed needs to mold to your foot. So you think about that process, and we go through that because we know what the end result's going to be, the best fitting boots that we can find in our budget and American company, right? Beautiful thing to support. But with audio, it can be just as fun, right? Without necessarily pain to your feet, right? So it's a matter of going through the process, changing things out, getting a sense for what you like. And in the end, then the family gathers around the couch. You get an awesome time to share with your family, and you can explain what's going on in the system, or just enjoy the movie.
So will these break in? Speaking of breaking
Absolutely. Yeah. So
there's this common like
I know.
Facebook group. The speakers don't break in, so they will
Any
change.
any mechanical device breaks.
Great, you took the words out of my mouth. So you have a suspension, and that suspension on all, even the tweeters, will break in.
Okay.
And it will change the characteristics slightly. You're gonna, the first week is gonna be the majority of the break-in, and then it'll continue to break in after it. Yeah, and so they will settle in.
They'll settle
and every
in and sound
speaker's
a
the
little
same
different.
way. Yeah.
So my system's going to be 5.2.4, right? So I'm going to have which we just opened, the R5 center. I'm going to put this. Do you think this? I'm going to put it on an iso-acoustic stand right here.
Yeah,
So it's
good
going to go
idea.
right here. So I'm going to decouple it from my cabinet. I could put it in the cabinet, but I want to put it on the cabinet because I always get yelled at for putting it in. Michael yells at me all the time, putting it in the cabinet.
Yeah.
So I'm going to put it here. I just took my other center channel off. So I'll decouple it from the cabinet, and I'll
Good idea.
try. So I want a straight line to my ears, right? Isn't that what I want?
Yep, exactly. Because that's going to anchor the image. So if you have a vocal that's supposed to be in the center, you want the speaker coming from the center as much as
Gotcha.
possible. That'll anchor the image for you.
And then I'm going to be doing. Tell me a little bit about the R210.
I can't wait for you to open that. I can't wait to
Well, let's open it right now. Let's
Okay.
go.
All right, you're going to need some help with that. Okay. Ready?
Yep. Let's do it right here. So, in a perfect world, I wanted to just do the D, do the big boy D series, but I ran out of money, and so I have to do the R series.
But that's the ultimate question to ask me, because that lets me say the thing I love to talk about our subs. And Michael, when he was at Perlisten HQ, we talked about it. Our philosophy with subwoofers is to scale SPL, not sound quality. So I don't believe in making your flagship have all the features and all the sound quality capabilities and then dilute to go down in price point.
Okay.
Here in R210S, it's push-pull, right? So we're gonna have the lowest distortion possible, sealed box, nearly perfect transient response. All those characteristics are very similar to a D215S. What's the core difference? How loud the two can play.
Okay.
So at what SPL or what room size do you need to fill? That's your choice. So you're not really sacrificing much, if anything, in the sound quality factor. And so people, if they want to start at Perlisten, if they start at a single R210, they know they can add more R210Ss to achieve that D215S. So again, we talk about the experience with the separates. You can do the same thing with the subwoofer. And that's where we're different than pretty much every other brand out there. There's distinguishing characteristics of a push-pull. Actually, you're going to want to, hold on guys,
you wanna-
1 second.
Yeah.
So the feet are right here.
Oh, okay.
So you can pull this
Oh, and go right to it.
and then take the sock down, and then you can flip it right onto its feet.
So if we just do this,
I should listen to the guys who make the darn thing.
so this is a great shot for the camera to see because the sub has woofers in two different orientations.
Okay.
So it's
this
not
is
your
passive. The passive radiator? Or
No.
no. Okay.
No, this is an active woofer, and it is not your traditional push-pull. The orientation is really cool. So one of them is down. That's obviously the magnet,
Okay.
the bottom of the basket, and the cone is firing that way. And then you're also going to see one front firing. So if you remember, Matt, back to when you and I were car stereo installers in our isobaric, this is a slight modification of what we would have called a standard isobaric.
Yep.
A
it
band
follows
pass, right? Band pass box, isobaric, where the woofer's firing the opposite direction.
By
Essentially.
working together, they cancel the distortion, and Dan can tell you way more about the tech than me. But I've been wanting to see your face as you get this thing out of the box since these things shipped. So I'm excited to see you.
So yeah, if we
I'll
just,
help you get it out.
there you go guys.
We gotta be a little bit careful how we tip that.
We don't
I think I got the best job. I just have to
Yeah,
watch
you be the answer guy.
We're good. We're good. I got my finger under that. There you go.
Awesome.
This is exciting.
Let's flip that over and I'll throw these in there.
Cool.
So these are going to go next to my cabinet there.
So you can see that side and the front have grills, and initially people think those are ports, but really that's just for the lower driver to pressurize the room, right? So we have grill on the bottom, both sides in the front.
So there's a 10-inch woofer here, and then a 10-inch woofer mounted.
So you did hit on it when you said they're opposite. So these are, let's see, mechanically opposite. So one's firing, pushing, right?
Okay, yep.
But because the other one's flipped, it's going in reverse, but they're both acoustically in phase, so that when they're pushing out, they're pushing in, they're pushing out, they're pushing in. But by flipping them mechanically, you cancel all the even order harmonics. So we see about a 10 dB attenuation of all the even order harmonics just by doing that configuration.
When we first launched the brand, the question we used to get all the time, because people were not used to seeing this configuration, was, oh, I think I just want the single driver because I want the lowest distortion. So, well, wait a minute. Actually, the dual driver gives you the lowest distortion that Perlisten makes. So, and it kind of freaks you out at first because all the things you're taught, a lot of us in audio may be taught, right, about how to do this, would say that the single would be the way to go. But because of the design, the distortion gets dropped. And as Dan said, realistically, every Perlisten is a phenomenal subwoofer. It's just about the size and scale. How big's the room? How loud do you want it? Right? You're not,
So I'm not
sacrificing
sacrificing combo.
Yeah, so if you
excited
decide
for
you
this.
want the lowest distortion, then we would get you into one of the push-pull subs.
Yeah.
And then you find out, you know, we always like to recommend multiple subs because that's how you'll get a more even response in your room. So let's say two R210s, which is exactly what you're doing here, which is a great place to start. And then if you decide when you're watching that movie or whatever, because this is a pretty big space, you might want more, you can add more of these same subs, and again, you're just scaling the SPL and not the sound quality. And we wouldn't say, oh, you got to take those back and put D215s in. That wouldn't be the solution I'd recommend. I would just say add more subs. And whenever the more subs, the better, because you'll be able to fix more of the room modes and have the SPL.
So my room's going to have two of these. I'm planning on putting them right there. Is that going to work? Do you want them inside or outside of the? I don't really have much of a choice.
Typically, if they're, we could try. And this is a huge room that opens up into more rooms, so it's not any standard room. So there's probably some experimentation.
Yeah.
Yeah.
So
You just probably want to avoid like putting them too far to the center.
Yeah.
But here, there's a huge path to there, so I would say we try them and we test them, and then we find out. Yeah.
So the rest of the system is going to be, and you're going to go over the Michael Stevens, the Youth Man channel, put a link in the description, where us and the rest of the guys, we kind of unbox, kind of put everything into position, and then follow-up videos where we actually, we're not going to get it all installed today. I have to cut the ceiling and do some more work. But the guys were in town for a few hours here, so I wanted to capture as much as I could. But you want to check that out on the Youth Man channel. But we're going to be doing S2s. So these are the difference between S2 and S3 is having the full DPC array versus.
These are a little bit different. You can kind of see it in the picture here. This is actually R series, so R2 number of drivers. So we have just the single dome with a very large waveguide.
Gotcha.
And again, here's a woofer that's recessed in, so kind of like the DPC array you were asking me about the grill.
Yep.
So we're doing a similar thing here where the woofer is underneath the waveguide, so the grill is part of the waveguide.
Gotcha.
So the difference between an R2 and an R3 is the number of drivers. We add another mid-tweeter. Again, it gives us lower distortion, higher power handling, higher sensitivity compared to an R2.
And then I'm doing what are the rears called? They're here somewhere.
R4S.
R4S, right.
Okay.
So those are going to be the slant style, and they're going to go where my current side speakers are. So just because of the way this room is set up, I'm doing the 4 Atmos. So those will be the R2s.
Awesome.
The 2 sides, I'm doing 5 bed layer channels, 5 channel surround, and then doing the 4 Atmos, and then the 2 subwoofers.
Actually, it'll be a pretty damn good experience in here.
I think so too.
It's gonna be awesome.
I may add some first, second reflection points if I can catch maybe on the wall. The problem is the first reflection point is probably right where the darn glass is, I would guess.
Yeah.
But we'll try to correct as much as we can with Dirac and room correction. But the system, I think this like I'm excited. Like I got those butterfly jitters of seeing the woofer and how the main reason. So when it started, when I first talked to you guys, I said the first thing that started was just like an attraction. Like there's like this. I get like this because I'm a product guy. I'm a spec guy. What does the experience feel like? Am I attracted to it? So the website. Everything you guys do has consistency. The boxes, the cabinet, now when I'm seeing it in person, I was able to play with these the other day or a few months ago. There's a consistent experience that just speaks to me. And with most electronics, most speakers, I mean, this is not stuff no one needs, right? This is a hobby to me. Actually, that word hobby is very deeply offensive because I don't do hobbies. Like I go in deep. So deep that we're starting a darn company to offer this stuff to people. But what I plan to do with Perlisten on the Youth Man channel and Obsessed Home Theater is to eventually we will have bought everything. So this is step one of buying, actually step 1.5 of buying a bunch of stuff. And we're going to play with it all and test it all and make decisions on which we think we want in our theaters, Michael and I and Rusty, and then we can impart some of that knowledge on you. So go check out the Youth Man channel for the rest of the install of this, and then we'll do some follow-up videos. But thanks for coming to my house, Dan, and giving us some of the story, the background of Perlisten. And I'm excited. This is going to be awesome. Thanks, Steve. Thanks, Dan. Thanks, everybody, for watching. We'll see you on the next one.